Jai Hind, everyone. Myself is Nikhil Kumar, the faculty of IT department in Akgec Engineering College. And today I have a lecture on theory of automata and formal language. Basically, it is the second lecture of this series. Tafl BCS. The code is the BCS 402. And today we will discuss the minimization algorithm of DFA. And what we have already discussed in the previous video lecture, we will also have the brief note. We will have the brief content to memorize that. We already discussed what is the automata, what is the notation of that automata, and what is the some structures, that is the what is the string, grammar, DFA model, NFA model with epsilon, with epsilon and without epsilon. These things are already discussed in the very previous lecture of the automata, and we are very sure that it is not to recall to this topic now. So the topic is the minimization of algorithm of DFA. Minimization algorithm of DFA. The DFA is basically the deterministic finite automata. It can be considered as DFA is also considered as the DFA machines. DFA model or DFA machines, both are the same thing. So when we minimize the DFA, we basically use 2 to 3 different algorithms we can use. So today we will discuss the minimization algorithm for the DFA that basically minimize the DFA states. DFA contains different type of number of states. Basically DFA, when we can say the DFA model, so we considered in our mind that it contains the tuples, a set of tuples that are the 5 tuples considered in the DFA model, that are the represent from the M, and that are the capital F, sigma, delta, Q naught and capital Q. These are the 5 tuples already discussed in the previous lectures. So that is not the need. Our focus is the Q, which contains the non-empty set of the finite automata. Basically, it is the non-empty sets, non-empty states, basically. So what we will do in this algorithm, we will minimize that states. Basically, our objective is to minimize the states. So in this algorithms, what we will do, first we remove the unreachable states. So the first step will be the unreachable states. To remove the unreachable states. What is the unreachable states? For to understand this concept, unreachable state, think about such scenario. Let's suppose this is a initial state Q naught and Q1 is the intermediate state, and let's suppose Q2 is the final state, and there is also a state Q3 which is mentioned here. This is basically a finite FA model, finite automata model. So when we discuss about the unreachable state, so the state which cannot be traversed from the initial state is known as the unreachable state. For this context, the Q naught is the initial state, Q1 is also go through from the Q naught, Q2 also go through from the Q naught, but this state Q3 is basically the state which cannot be reached out from the Q naught. So in the process of the minimization algorithm for DFA calculations, first step is the remove the unreachable state. Such type of states that cannot be reached from the initial state is basically eliminate from the model or in the transition table. The second step will be draw the transition table for the rest state. Let's suppose there is suppose there are q state which contains q naught to qn total states. So we design the qn minus 1 state, q naught to qn minus 1 state transition table. If in the case the one state q1 or any other, let's suppose q1 is the unreachable state, then we eliminate q1 from the transition table and generate the remaining states transition table. Then the step third is the split the transition table into two tables, T1 and T2, such that T1 contains the all row that start from Q minus F, where Q is the set of early state and F indicate the final state. That means all the states that, let's suppose for example that Q naught is the initial state, Q1, Q2 and Q3. For any input symbol, let's suppose AB, AB, AB. This is the, let's suppose this is the structure. This is the structure for this one. So what we will apply? For to calculate the Q minus F, that means there are 4 steps, 4 state Q naught, Q1, Q2, Q3 are the considered in the Q naught, Q1, Q2 and Q3. For the case of the F, for calculating the final state F, there is only the one term Q3. It is a basic single state. Q3 is the considered as the final state. So when we calculate Q minus F, that means Q naught, Q1 and Q2. So the T1 table contains only the Q minus F state and T2 contains the remaining state that contains the final states. So what we will do after creating two tables T1 and T2, find the similar row from T1 such that delta QA equal to P and delta R comma A equal to P. That means both contains, if both contains the same value, what we will do next we will be discuss. First it is necessary to discuss what is the delta function if you don't know. So delta in the transition table, or we can say in the DFA model, is basically a functions that generate the next state after apply the input symbols. After apply the input symbols in the given state. Let's suppose Q1 is basically a state where we will discuss, and we will and we want to find out the next state. So it will be represented in such way that delta Q1 comma A, that is the input symbol. After apply this one process, the state will be the Q2, and Q1 after apply the input symbol B, the resultant value, the next state will be the Q2. In both the case, the state will be the Q2 according to this structure. So this is the transition function. In the case when we generate the transition table in the T1 table, we find out all the states. We will check out that in any case the transition function contains the same value in the row. So what we will do? We will do apply the, we replace R with Q in other rows. That means we replace all the rows that are common in nature and replace with the earlier states. Repeat this state, step number 4, until there is no common rows available. And the step 6 says repeat the step 4 for also the T2 table. That means we also contains here only the for the T1 table, but when the process of the T1 is complete, so we will do for the next, that is the T2. The next step will be the now combine the reduced, that is the updated T1 and T2 table, and the combined transition table is minimized as the DFA. So after apply this process, the number of states, that means Q, will be minimized. It is the basic the full steps step 1 to 7 are the intermediary process for to calculate the minimize algorithm for the DFA. So for this, to understand basic these principles, we should be use the a questions that describes this one. Let's suppose there is a Q naught is the initial conditions, initial state Q1. Yes, from the input state from the state Q naught to Q1, if we apply the input symbol 0, then the state will be changed, and there is a 0 input symbol from Q2 to Q1. We apply the input symbol 0 from the Q2 to Q4. If we apply the 1 input symbol, then it goes to, and Q3 is also considered as the final state. For the case 0 to 1, 0 and 1 input symbol, we goes through the state Q5. So basically this is the questions, and we will apply all the process. So for what we will do, we first generate the transition table. For the step 1, we eliminate if any inaccessible state exists, then we will remove that. So we will check all the state are accessible or inaccessible. So Q naught is the accessible, Q1 also accessible, Q2 also, Q2 is this state Q2 is not the accessible. The reason behind that, we cannot move from Q0 to Q2, so we will eliminate this Q2, and using when we eliminate Q2, the basically Q0 Q4 also eliminate. So we reduce from the transition table both the states. After eliminate these two states Q2 and Q4, the resultant transition table will be look-wise, will be seen look-wise that for the input symbol 0 and 1, sigma input symbol transition Q0, Q1, Q3 and Q5. We eliminate the Q2 and Q4 states due to the from the Q0 to 0 apply have the value Q1. For the one case, it goes to the Q3. For the Q1, it comes to Q0, and for the Q1 case, it goes to the 1. Okay. So it comes to the Q3. For the Q3 case, all comes to the Q5 after apply 0 and 1 input symbol. For the Q5 case, it will be the Q5. So it is basically not the very large type of models. It is a very common questions and not so much complex for the understanding purpose. So what we will do, so here it is a transition table T. We eliminate, we will discriminate this one into T1 and T2 according to discussed as per the transition table, as per the rules. That is the step number 3. We split the into T1 and T2. For the T1 case, the state, that is the initial state Q2 and Q3 and Q5. It is the final state. So Q0, Q1, 0 and 1, Q1, Q3, Q0 and Q3. This is a T1 table, and for the case of the T2, we will generate this table here also 0 and 1. What will be? It will be Q3 and Q5, Q5 and Q5, Q5 and Q5. So the important thing what we have to be noticed here, that when we will check in the T2 table, we check that the transition function for the Q3, after apply the input symbol 0, the resultant value goes to the Q5, and for the case Q5, after apply the input symbol 0, it goes to the Q5, and it also comes to the one input symbols. That means in both the case it is the common portions. This row is common here. So what we will do, we will remove this row from the previous one Q3, and we will use Q3 replacing by the Q5 in all the transition table. And what we will do now, we will merge T1 and T2 to compoundly calculate the transition table. The resultant value will be I write down here 0, 1, Q0, Q1 and Q3, Q1, Q3, Q0, Q3, and here Q3, Q3. So this is the transition table for the resultant finite automata model. So according to this, we will find out the resultant model. We will mention here Q0, after apply the input symbol 0, it goes to the Q1, and apply the one input symbol is come to the Q3, and when we apply the input symbol 0 on the state Q1, it comes to the Q0, and it comes to the Q3 when apply the input symbol 1. For the case of Q3, it is self loop for the input symbol 0 and 1. This is the basically resultant minimized finite automata. Actually, in the starting, what we will have, we have the 5 1 2 3 4 5 6 state finite automata, but now after minimize this one, we only have the 3 state. This is the basic principle of the minimized finite automata model, and this is the first algorithm. In the next video lecture, we will discuss the other one, minimized finite automata model. Thank you.